Hello everyone. This video is to refer the earlier video what we have done, where we have made a discussion on Pinacol Pinacalone rearrangements. So there we have discussed about different migrating aptitudes and so on. In Pinacol Pinacalone rearrangements, the migrating aptitudes are different from that what we have generally seen in carbocation rearrangements, or maybe reactions like beer vinegar reactions and so on. Particularly in Pinacol Pinacalone rearrangements, they are stereospecific rearrangements. Pinacol rearrangements migrating group retain its configuration. Migrating group retain its configuration. So it is a stereospecific condition. This is the reason why we cannot fix the migrating aptitudes of groups in Pinacol systems. So we cannot fix it. So like carbocation rearrangements, migrating aptitudes of methyl or hydride or phenyl, as such we cannot fix anything. So it is the fashion of migration is somewhat different compared to other type of rearrangements, in particular in Pinacol systems. So all these things are experimentally we have to decide which group has migrated, but theoretically it is not possible to explain this. The actual migration, let me explain that. The actual migration depend upon substrate and also the reaction conditions. For example, sometimes hydride ion migrate, sometimes phenyl ion migrate, sometimes alkyl system migrate. That depends upon what substrate you have taken and what are the factors or sterical conditions affecting the substrate, along with the reaction conditions provided. Right? If I have provided very low temperatures, that means a cold and concentrated H2SO4, or if I have provided weak acid, acetic acid conditions, then the migrating aptitudes will completely different from that what we have expected. So let me see this. If I have taken an example, this is a phenyl, this is phenyl OH, methyl OH. If I have taken this, when this is allowed to react with H2SO4 at cold condition, generally what we expected, there will be formation of carbocation at system where both phenyl groups are present, because the carbocation generated here will be more stable carbocation. So obviously, so this lead to product formation. The product formation will be phenyl methyl. Here this converts into methyl and this is ketone. Right? This is the product where methyl migration happen. So here methyl migration occur. So this methyl migrated product is approximately 83%. That it doesn't mean purely methyl group got migrated. So you will have some other byproducts also, but major is migration of methyl group. So instead of this, if I have taken acetic acid, when we take acetic acid in presence of traces of H2SO4, and we have traces of H2SO4 and acetic acid. Now the obtained product will be this is the product obtained. So from here what we can conclude, there is migration of phenyl group and carbocation is generated not as the fashion what we expected. So carbocation should generate on the other condition. So here we got the product through phenyl migration, and here the obtained product will be approximately 77%. So these are the experimental evidences. So based upon the products generated from experimental data, we try to bring some reasonable explanation for it. So let me go through that. When we have taken a strong acid, right? So based upon the strength of acid, based upon the acid strength, right, in which the reaction carried out. So acid strength of the reaction medium, migrating aptitudes do alter. If you take stronger acids, in stronger acids, for example, if you take H2SO4, methyl group migration predominant. Methyl migration predominates. There must be some driving force to make methyl group migration dominant. Here the driving force is stability of carbocation. Already we know that tertiary systems become more stable and so on, right? So here the driving force is stability of carbocation. This is the reason, let me check that. So when you have taken any strong acid, or for example if you have taken H2SO4, which is a strong acid, there methyl migration is dominating factor. So here when you take H2SO4 as strong acid, when you get positive charge here, that carbocation will be in conjugation with both phenyl systems, so more number of conjugations, therefore the stability of carbocation is high. So that leads to positive charge over this carbon, then methyl group will migrate, leading to the methyl migrated product, Pinacalone. When you provide weak acid, however, if you take acetic acid, that means nothing but weak acid, now reaction do not proceed through formation of carbocation or something like that. So here reaction now proceed through concerted mechanism, right? So a concerted mechanism occur. Such that means it is passed through a transition state, right? So the group with higher migrating aptitude, higher migrating aptitude, that means in this case phenyl is the one that actually move, that actually move. So instead of forming carbocation here, because of a concerted way, because of the migrating aptitude of phenyl, that decides which OH group to be eliminated, that means from which position H2O to be eliminated based upon the migrating aptitude of the system. When you have taken weaker acids, right? So here actually the reaction starts with the mechanism of this concerted reaction, of this concerted reaction actually starts with protonation of OH group. So instead of losing H2O plus H2O first, the migrating aptitude will make the H2O group to leave, right? That means as the water molecule leaves, as the H2O leaves, the migrating group simultaneously moves, forming protonated ketone. So observe the difference. So we cannot fix migrating aptitude always in the same fashion, right? So this is how the products vary, right? When you have taken stronger acids, because of presence of strong acid, free H plus ions are available. Because of free H plus ions available, H2 is lost, forming a more stable carbocation. As we are getting more stable carbocation, then group which is anti from the other system will migrate, leading to methyl migration in this case. When you take weak acid, as it do not provide H plus ions freely, this has to abstract H plus. That means there is no generation of group in this manner. So there is no generation of this part. This is not generated. H2O plus is not generated because we have provided weak acid. If as this is not generated, there must be some other group which makes the OH group to leave from that position. So here phenyl group plays a role. So because of better migrating aptitude of phenyl group, this phenyl group tries to shift its pi bond over the carbon and making the OH2 plus group to leave. Therefore phenyl group migration predominates. So that means we cannot fix the migrating aptitudes of any group as the same in every condition. It depends upon the reaction conditions and the substrates taken, as well as the acidic natures and many other factors do dominate, right? So we cannot blindly follow a migrating aptitude order here. So many other factors plays a crucial role. So we must be careful what are the conditions provided, what is the substrate, and which may be the dominating product. So we have to consider all factors to decide the migrating aptitude or to decide the final product generated, right? So this is what we need to discuss. This is completely related to Pinacol Pinacalone rearrangement, which we have discussed in our earlier video. Right, that depends on the type of substrate we have taken, as well as the type of reagent we have considered. Right, thank you.